Hi, I'm Elizabeth with Logic Walk, and welcome to Chapter 2 of the Operating Systems course. In this chapter, we're focusing on one of the most important components of any operating system, the file system. You've probably used a file system countless times without even thinking about it. Whenever you save a document, download a photo, or organize files into folders on your computer, phone, or tablet, you're interacting with a file system. It's what allows the operating system to store, locate, and retrieve information so seamlessly that it feels effortless to us as users. In the Computer Architecture 2 course, we learned how computers write to and read from the hard drive. We even created two shell commands, W for writing data and R for reading data. For example, suppose we want to write the name John to the storage device. We can use the command shown on the screen. This command writes John to the hard drive starting at index 3. Later, when we want to read that same data from the hard drive, we can use this command. This command tells the computer to read 4 characters from the hard drive, beginning at index 3. While the R and W commands are much more convenient than assembly language instructions, we still need to be cautious because it's easy to make mistakes by accidentally typing the wrong number. For example, suppose you want to read John from the hard drive, but accidentally enter this command. This command won't give us the intended result. It tells the computer to read 3 characters starting at index 4, which would only return OHN instead of John. As the amount of data grows, keeping track of where information starts and how long it is becomes nearly impossible. Imagine trying to read an entire book from the hard drive. You'd have to remember both the index where the book begins and the number of characters it contains. Even more concerning, one small typo could overwrite data that's already saved on the drive. A single wrong number could erase or replace something important. Because remembering numerical locations is so difficult, programming languages introduced a helpful concept, assigning names called variables to memory locations. Operating system engineers applied that same idea to hard drives by assigning names to data. In operating systems, this named data is called a file. In the Logic Walk OS, we can use the write command to create files. For example, suppose we want to create a text file named my name that contains the text Jonathan Jordan. We can type the command shown on the screen. File names are typically divided into 2 parts, the name and the extension, separated by a dot. The name is the text to the left of the dot. So my name is the name of the file. The text to the right of the dot, in this case txt, is called an extension, and it identifies the type of file. The file we just created is a text file, but other extensions you might see include PNG for images and MP4 for videos. Now imagine we want to read this file from the disk and print its contents on the screen at the same time. We can do this using the cat command, followed by the name of the file. Unlike the shell commands we created in the Computer Architecture 2 course, the cat command only needs the name of the file. It doesn't require the size of the file since the operating system automatically keeps track of file sizes. The command shown on your screen demonstrates how we can use it. Typing this command prints Jonathan Jordan on the screen, the text that was originally stored in the file called my name. If you try to use the cat command with a file that doesn't exist, the computer will display an error message. It will show a copy of the command you entered, followed by the message, no such file or directory. This tells us that the operating system couldn't find the file name we specified. One of the biggest benefits of using a file system is that it allows us to write data without worrying about accidentally deleting or overwriting other files. For example, if we want to create another text file, we can simply use the write command again, this time with a new file name. The command I just entered creates a new file called his name that contains the text Mike Smith, while leaving the first file we created completely unaffected. As simple as these commands are, we need to pay close attention to how we type them in the shell. For instance, let's see what happens if we add spaces to the text. Imagine we want to create a file that contains the text Billy Idol with a space in between. Typing that command results in an error message that says usage, write path data. In the shell, spaces are special characters that separate arguments. The command we typed is interpreted as 3 separate arguments, but the write command only supports 2. The text to the left of the space, which is the file name, and the text to the right of the space, which includes the text to write. Because our command contained 3 arguments instead of 2, the operation was terminated because the shell wasn't sure what to do with the 3rd argument. To fix this, we can surround the text that includes spaces with double quotes. By using quotes, the shell treats everything inside them as a single argument. Watch what happens in the shell. We created a new file containing the text Billy Idol with the space included, and then used the cat command to print Billy Idol on the screen. The write command is fairly simple and not designed for more advanced tasks, such as creating multi-line files or editing existing ones. For those tasks, we use text editors like VI or Emacs. And in graphical operating systems, such as those on laptops or tablets, we rely on graphical text editors like Microsoft Word or Google Docs. Now let's consider another scenario. Imagine we create a file named location that contains the text Texas. And a few moments later, we try to create another file with the same name but update its contents to Arizona. This would overwrite the original file, erasing its previous data. To create a new file, we must assign it a unique file name. As we can see, the location file initially contained Texas, but after rewriting it, the file now holds Arizona. At first, giving each file a unique name might seem easy, but what happens when our hard drive contains millions of files? How can we name and remember each one so we can retrieve it later? That challenge brings us back to the same problem we were trying to solve in the first place, keeping track of where everything is stored. This wraps up our lesson on files. In the next lesson, we'll explore how operating systems solve this problem with folders, allowing us to organize and locate files more efficiently.